Okay, we're on example 1 on page 193 for section 4.3. Okay, so it says the point A, and remember our points are x and y, but they're also cos and sine when we're with the unit circle. So our point A lies on the intersection of the unit circle and the terminal arm of an angle in standard position. Draw a diagram to model the situation, and then determine the values of the 6 trigonometric ratios for the angle. Express your answers in lowest terms. Okay, so if we were going to just a rough picture of what this would look like, we have two negatives, so which quadrant's that going to fall in? The tangent one, yeah. So in the cast situation, it's going to end up here. So all they really want for a picture is where it would end up in here. It doesn't have to be accurate about where it is, but so we would just say the point would end up in that quadrant here, okay? And so question B says they want the 6 trigonometric ratios that go with it. So remember, the 6 trig ratios are sine, cos, tan, and then the opposite of sine is cosecant. The opposite of cos is secant, and the opposite of tan is cotangent. Okay, so we'll just go through them. These are the 3 ones that we're familiar with, and these are the opposites of them, so the reciprocal. Okay, so if we need a refresher, sine is equal to 1 over cosecant. It just means whatever your sine is, if you flipped it upside down, that would actually be cosecant. And the same goes with cos. Cos, the opposite or the reciprocal of it is secant. So if we flipped it upside down, it would be secant. Okay, so do we know what sine is in this question? Yeah, he's negative 4 over 5. Okay, so I just said cosecant's the reciprocal, so what would cosecant be? Well, he'd just be the reciprocal of them. So he'd still be negative, but he would be them switched around. Cos, we know to be as this point here, right? Minus 3 over 5. And then we can say secant is the reciprocal of cos, so he is minus 5 over 3. And then tan, how do we find tan? Anybody remember? Okay, so here, remember when you guys were laughing at me the other day because I said Sir Coxer Yeah. Okay, Sir Coxer just stands for, like, when we're on a Cartesian plane here, this is x, this is y, and this is always the radius, right? So it's still SOHCAHTOA, it's just using x, y's, and r's instead of opposites, adjacents, and hypotenuse, right? So if we were from here and we were going sine is opposite over hypotenuse, which is y over r. That's where the SIR part comes from. And cos is adjacent over hypotenuse, which is x over r. And tan is opposite over adjacent, which is y over x. Okay, so if we think of these again as x and y points here, this being x, this being y, then we should be able to find out what tan is, because tan is your y over your x. Okay, so if tan is y over x, then we would be putting minus 4 over 5 divided by minus 3 over 5. Okay, and does that look like we can leave it like that? No. We can't have fractions over fractions. So to get rid of this fraction, what this is saying is, it's actually saying minus 4 over 5 is being divided by minus 3 over 5, right? So if we want to divide fractions, we multiply by the reciprocal. So it would actually be multiplying like that. Okay, so remember, if there's tops and bottoms, we can cross off just to make it a little bit easier. We can do that. So these become 1 and 1. So then we have minus 4 times a minus 1 is 4, and 1 times 3 is 3. So our tan value, simplified, is 4 over 3, meaning our cotangent value would be 3 over 4. Okay, example 2. Exact values. So to find the exact value on the diagram, all we need is our unit circle that we drew. Okay, so if we want to find the exact value for cos, remember, cos is our first point, of 5 pi over 6, you should be able to tell me what it is by looking at your unit circle. Okay, my unit circle is somewhere here. Okay, so 5 pi over 6 is here. So then the cos part is this guy. So the exact value should be minus root 3 over 2. Okay, so we can do the same here. Sine, except we have minus 4 pi over 3. Okay, so the only difference there, let's go to our unit circle, is we would be heading this way around. And we'd go to, where are we going to? What's that? Oh, no, we're heading here, I think. There. Are we not? Okay, since we're looking for negative 4/3, we're going to go clockwise around. So we're going to go, this is 1/3, 2/3, 3/3, and sorry, my arrow should have went to here, to 4/3. Okay, so we're actually at the 2 pi over 3. Yes, that is clockwise, right? Okay, okay. So the sine point would be what for this one? It would be the 3 pi root 3 over 2. Okay? So this would be our exact value. Okay, so now we have something in degrees. So since we were looking at radians, we might want to switch him to radians so we can check on our unit circle. So to switch something to radians, you times by pi over 180. Okay, so then you'd have 315 pi over 180, which can reduce to what? I honestly don't know, so we'll have to reduce it. Okay, so when we reduce it, we get 7 pi over 4. Okay, so we're looking for 7 pi over 4, so we go to our unit circle. It's getting all messy here. And 7 pi over 4 is over here. And we had secant value of that. So remember, secant is when you flip cos, because cos is equal to 1 over secant. So if our cos point is root 2 over 2, this is our cos point, root 2 over 2. Our secant point is 2 over root 2. And we can't leave it like that. So we multiply by root 2 in the top and the bottom. And we just end up with 2 root 2. And root 2 times root 2 is root 4, which is just 2. And so these guys can cross off. So our answer should just be root 2. Okay, example 2, we're still on, and this is the last one. So we have cotangent of 270. So let's figure out what that would be as a degree, or sorry, it is a degree. Let's find out what it is as a radian. So 270 pi over 180, we can reduce that. So I can take tens out, and then I can divide by 9. Can I divide by 9 in each? So that would leave me with 3 here and 2 there. So I should have 3 pi over 2 when it's reduced. So cruise back to our unit circle. 3 pi over 2, 270 degrees is right there. Okay, so mine's a little messy, but is that the point of 0 and minus 1? Okay, so these are our x and y's, right? 0 and minus 1. Okay, so our point was 0 and minus 1, but we're talking cotangent. So this is our x, this is our y. Remember cotangent, and I said that Sir Coxer Tix Delio, Sir Coxer Tix, is always y over x. So if tan is y over x, cotangent is the opposite of that, meaning it would be x over y. So it would be 0 over minus 1, which is just 0. Okay, example 3 says determine the approximate value for each trig ratio. So as soon as we have approximate value, that usually just means you're using your calculator. Okay, and give your answer to 4 decimal places. The key here, though, is if we are in radians, this guy is radians also because he doesn't have a degree sign there. So don't get tricked by the sign in front. He's still in radians. Okay, and these two guys are in degrees. Our calculators are always in degrees, but we can switch them to radians by going into your mode. So for these ones, you're going to have to switch them to radians. Okay, so I'm going to press pause while we figure out how to switch them to radians, and then we'll do these 2 questions. Okay, now that we've switched the mode of our calculator, we're in radians for these 2 questions. Then all you have to do is simple calculations. So you'd go 7 times 3.14 divided by 5, and whatever decimal you get there, you hit tan that decimal, and you should get 3.07-ish, depending on if you use 3.14 or if you use the pi button. Okay, in this situation, we're already at a decimal, so all you have to do, since we're in radians, is hit sign. 4.2 equals on your calculator, and you should get negative 0.8716. Oops, now I wrote it backwards. 8716. Okay, for these last 2, all you have to do is go back to your normal degrees and then just hit cos 260 and you'll get a decimal. Okay, so you need to switch your mode back to degrees in these 2 questions. So go back to DEG for these. Your answer should be negative 0.1736. And in this situation, it should be negative 1.0642. Okay, example 5, we have the point A, and our x is minus 4, and our y is 3. So if you think about it on our Cartesian plane, if we went 1, 2, 3, 4 to the minus over, and 1, 2, 3, our point would be right here, okay? And we could draw our radius straight out from there. So remember, we always used to draw our triangles, right? So this guy is minus 4 over. I missed it by a little bit. And this guy is 3 up, right? And this guy is our r. So our x is minus 4, our y is 3, and our r is we don't know. Does anybody remember how we always found that out, what the r was? This is a right triangle. Yeah, Pythagorean theorem. This guy. So like 3 squared plus minus 4 squared is equal to r squared. Okay, so 9 plus 16 is equal to r squared. When I add those together, I get 25 is equal to r squared. So I root, and I get r is equal to 5. Okay, so now we have our x, our y, and our r, so we can use Sir Coxer Tix to find each of the trig ratios, okay? Because sine is going to be y over r, y being 3 and r being 5.